So yeah, let's start from the beginning. Yeah, let's talk about security. Yeah, my name is Andrey, and I usually position myself as a developer because I am a developer. I write code. On the other hand, I'm doing a lot of other stuff. I'm a DevOps person. I'm helping people with company automation. I'm speaking. I'm training. I'm also working as a CTO of a small company nowadays. But at heart, I am a developer. Right? That's an important thing. So yeah, let's talk about supply chain because that's what actually the title of my talk, which was advertised in the DevClub. And yeah, I would like to discuss that. And you know, how many of you actually are DevOps engineers here? Like 10%. Developers, testers, security guys. Folks. That's awesome. That's awesome. Well, of course, you all participate in this, you know, supply chain creation, right? You manage devices, services, vendors, libraries, tools. You create pipelines. You manage data storage. You collect logs. You analyze metrics. You all know that that's the attack surface, right? That all can be attacked. And of course, we have to take care of that. And I mean, the more we go, the more technology we introduce into the world, actually the bigger the attack surface becomes. Yes, it becomes simpler in some situations, but in general, the attack surface increases every year. And we get more and more stuff of that. And yeah, before we go to that, do you know this term, this idea, this concept, wall of confusion? Anyone? No? It's actually a very old one. It's from where DevOps has started. DevOps engineers should know that. That, you know, back in the days, we have devs, we have ops, right? And devs were just giving the packages, applications to the poor ops guys, and those guys had to deploy them, right? There was a lot of confusion about what should be deployed, how it should be deployed, how it should be configured. And I mean, wall of confusion as a concept is still there. Of course, we course, we have lots of problems, lots of issues, and of course, the idea of DevOps and of DevSecOps and of, you know, better quality of software delivery in general is that we shift left, right? So we don't introduce walls, we introduce automation, obviously, and we introduce better communication between the teams, between different professions in IT, like developers, operations, security guys, security people. We all have to communicate in order to find the problems, find the issues as early as possible, right? So we're shifting left. So if you imagine the pipeline, right? In the end of the pipeline, we have a qualitative product. But if we find the problem in the end of the pipeline, that's too expensive. If we find the problem in the beginning of the pipeline, obviously it's cheaper and easier to fix and faster to fix and definitely better for the quality. Of course, not every problem can be caught in the beginning, but we should, as IT people, do as much as we can to catch it in the very beginning. So shift left security, maybe you've heard that term as well. And you know, if you were in the industry for some time, you probably know that devs and ops they still arguing from time to time about what's good, what's bad. QA people part of the conversation as well, but quite often security was left out. Right? Security was considered as afterthought. We were speaking about security only when there's a breach, or when we have the budget, or never. Right, so of course, the idea of DevSecOps in general, that we move the security feedback as early as possible into the pipeline and into the process of software delivery. Right. Question to you guys. Do you have a security team in your organization? Have you seen them? Okay, I guess those folks who are actual security guys, were raising their hands. I mean, having a security team is a good thing, absolutely a good thing. But if the security team is working by themselves, without interacting much with developers or operations or anyone else, then we're basically back to the wall of confusion, right? So you have one part of the organization that delivers software and another part that checks that the software is secure, and they never agree, right? And that's the problem I see quite often happening in big companies at least. That you have a security team, it works in some way, it does something, but developers really rarely see the members of the security team. and they only see them when there's really like a real problem happening. Right, so of course if you have the luxury of having a security team, that's good, but my opinion is that security teams should be visible. They should facilitate the education of security patterns and concepts and improve not just the systems, but also the people. Right? My firm belief is that security is everyone's responsibility, so you cannot delegate security just to the security team. You have to be responsible for that. The same thing actually with quality. You cannot delegate quality to the testers. Right? Quality is the responsibility of everybody, the same as security. And security, in my opinion, security is just one of the properties of the good quality software. Right? So yeah, that's an important concept. For developers, have you heard this thing?
Definitely.
Yes, finally. Finally, well, the cool thing about 12-factor up, it's actually quite old. Like it's 2011. The manifesto was introduced. And I mean, initially, well, I guess you've heard the term cloud native. Basically, 12-factor app is cloud native applications. And initially, it was really about the design of the app to make it more applicable to run it inside the cloud environments or in environments that are sort of prepared for automation. Because nowadays, when you say cloud native, it doesn't mean that it runs in the cloud. It actually means that you can run it in any environment that is prepared for that. It's like a local Docker container, or it's like a fully blown cluster, Kubernetes cluster running in the cloud. Application, if you can run your application in local environment and in Kubernetes, then your application is cloud native. If you cannot run your application locally, but only in the Kubernetes cluster, I would say there's something fishy about that. But so yeah, the 12-factor app was about designing the app that is ready to be easily maintainable, easily automatable, easily trackable, traceable, and so it's easy to scale it up, right? You get many factors in the app that like it's disposable, it's concurrent, it's stateless. We have one log stream. It really makes it easy for the app to be scale up, scale down, introduce concurrency as needed, consumes logs and stuff like that. So it's really operations-oriented design. On the other hand, it's also, to some extent, simplifies security, right? So things like isolated dependencies. So, for example, you don't want to depend on the wildcard version of something. You don't want to depend on the latest version of something. You want to depend on a specific version of the library. And from build perspective, that's a good thing because it's predictable. From security perspective, it's also a good thing because it's predictable. And you can definitely know what other vulnerabilities. Also, from the fact that you have one pipeline, it's also easy to trace from where this thing was deployed and released. So it's also a security thing. What else? What else? I mean, of course, also the other thing that we can expose the ports, network services, and we consume network services also makes it easy for, organize the networking perimeter and set up the firewall rules or network policies to actually make it more secure. So cloud-native applications, the 12-factor app application, is something that not only good for the cloud, but actually also good for security. That's one thing. And of course, with time, because the manifesto is quite old, people started introducing even more, factors into that. You probably, if you Google now, you can find like 15-factor application or 18-factor application. And basically, most of them are focusing around security, right? So in here, like in the original one, it was not super obvious that it's about security. But with more and more time, more factors added to that, it's actually obvious that we, as an industry, focusing on security more and more and more. And of course, secret management is one of those. Authentication authorization is quite often becoming, the part of the application from day one. We are already exposing telemetry. We don't even need to think about that because it's part of the libraries that we use. And API first, that's kind of expected already because we don't deliver applications that don't have APIs usually. Right. And of course, this term. What's good thing is that this standard it's maintained, right, and it's developing. And what I see as well is that developers actually becoming more aware of different things that defined in the top 10 of vulnerabilities or like risks that was defined, and that's actually becoming common knowledge. Let's say 10 years ago, 15 years ago, when I was mentioning the word of WASP, I saw like blank eyes, right? Now, when we say that, obviously it's quite well known. If you still don't know that, look it up. Right. Speaking of, that was the application part. Now I'm slowly jumping into the operational part. Well, you know, people like defining manifestos. That's another manifesto here called 7-factor config. Take a look at that. It's just, you know, another way to look at the configuration, because if you are a DevOps engineer, you know that there's lots of YAML, right? Just pure YAML everywhere. And of course, managing that is not easy, especially if you have, like, you know, gigabytes of YAML files in your Kubernetes cluster. This manifesto at least, you know, helps out to organize the ideas around, you know, secure configuration, version configuration, and stuff like that. It's not, again, it's not something new or original, but it's helps to, you know, organize the thoughts. Yes, but let's talk about the pipelines. So pretty much, I guess, most of you do things like that. Right? You have some code, you have some pipeline, you have some artifact repository, you have some infrastructure, you deploy that application when it's being published to the artifact repository. And the good news is, it's awesome, it works, and it's kind of a default standard now. Again, like 15 years ago, 20 years ago, pipelines was just, you know, a cool thing. But nowadays, it's just, you know, standard implementation detail that that everybody expects to have. And of course, it brought a lot of attention from, it received a lot of attention from bad actors, from hackers, because pretty much every element in here is hackable, right? And it's an attack surface. So first of all, of course, Git repositories, or if you're not using Git, version control repositories. That's an attack vector that if, let's say, developer's laptop is hacked in some way, then somebody can commit the code as the developer. And that code could actually get in the pipeline and automatically deploy it here and automatically deploy it there. So it's an attack vector. So you have to protect your Git credentials, two-factor authentication. If you're still not using that, you should. CI/CD pipelines. I mean, again, if you're using the tools that are running on-prem inside the organization, then maybe you're more safe. But nowadays, of course, you know, lots of CI/CD tools, they actually are provided as a service, which is a good thing. Like you have GitHub Actions or GitLab pipelines, or you have like Bitbucket pipelines, whatnot. And those services are, you know, hosted outside, right? And of course, there is a security risk in there that malicious code will get into that and will, you know, affect your delivery pipeline. That's definitely a risk there. And for artifact repositories, that's also a problem. And infrastructure as such is also potentially a problem. The other thing that you have to consider as a, you know, IT team member or the organization that delivers software, you have to see where the risks are, because of course you know that there are different ways to deploy your software, right? And of course you can select the version on the left. You run everything, but then the problem is that you have to maintain the security of every component in that list, right? So if you're running your network, your storage, your servers, it's your responsibility to handle the security of those elements, right? If you delegate, if you let's say outsource the runtime of your infrastructure to someone else, if you use infrastructure as a service, let's say in Amazon or Google, or use some platform like Elastic Beanstalk or, I don't know, Heroku or, I don't know, something else, then you again you delegate the security to them. Of course, you have to trust them that they're good actors and they will you know, tell you if something is going wrong. Of course, you can also use some software as such without even building that. Just you know, Microsoft Office, for example, in the web, you can use that as well. And of course, it's your choice, right? It's your choice. You have to understand that with more components, you actually introduce more risk. The attack surface is increasing. Right. Yeah, let's not talk about that. Yeah, let's talk about this one. So the attack surface is, if you talk about applications, of course, that's usually is here. But of course, and then this guy is controlled by the developers, right? So developers should know how to write application that is 12-factor or 15-factor if you wish, they need to know if there's anything that might be like a dependency that is vulnerable. But the rest of the things is controlled usually by operations people, by DevOps people, if you will. And of course you have to know whether your runtime, say Java, Ruby, or Python, whether it's vulnerable or not. You have to know if your container engine is vulnerable or not. Well, actually, there were several vulnerabilities that affected the container engine, depending on you're running that. You also have to make sure that your host is not vulnerable, so operating system. And you also have to make sure that, of course, the rest of the infrastructure is not vulnerable, because that's even bigger. So developers actually take part on this thing. So we can potentially control, the quality or the security level of application using pipelines, using things like Zap, for example, or different tools that do security scanning of the app. But of course, the rest of the infrastructure can also be controlled in some way, right? There's no other way. And there are many security concerns there. And let's talk about different vulnerabilities. Maybe you've heard of them, maybe not. Have you ever heard about Heartbleed?
Yes.
Is anyone who haven't heard about that? Shell shock? No. Well, shell shock was a bash vulnerability where you can actually, do the stack over, like buffer overflow in bash, and you get access to the root of the host if you're lucky. Meltdown?
Yes.
Yes. Spectre? Yes. Log4Shell? Yes, Log4Shell is probably the most famous one because, it's Java, right? And Java basically is dominating enterprise, and most of the enterprises all over the world were affected. And the funny thing is that, maybe you also have seen the situations, I've met companies which had vulnerable applications, and they were running in production, but they didn't have the source code for the application. So basically, they had to decompile, remove the class files, and the references, update the libraries. It was a bit of a hell. SolarWinds? Anyone? Yeah. Actually, I will not focus on SolarWinds because next speaker, will actually talk about that more. But yeah, these are one of the well-known, so to say, the vulnerabilities. Of course, there are many more because many of these vulnerabilities, like Heartbleed, I think is 2015. Shell shock is about the same. Meltdown, I think, was 2016 or something. The interesting part of Meltdown and Spectre is that this is actually hardware vulnerability. It was an issue in the Intel processors, which you can exploit, right? So basically, your application can potentially get data of another application running on the same machine, which is probably okay if you're running, just one application. But let's say if you're a cloud provider and running several independent vendors using a shared virtual machine, that could be a huge issue, and it was a huge issue because of course all the cloud providers had to patch their OS distributions and eventually also update the hardware. And I mean, imagine if you, as a company, have to run the hardware yourself, and then something like Spectre is being discovered. What do you do? What's your reaction? How fast you can actually react to that? I mean, it's part of your delivery chain. It's part of your supply chain. It's your infrastructure, and of course, you have to be able to react to that as fast as you can. Well, my main point here is that, of course, vulnerabilities, they do happen on every level of the infrastructure, starting from the hardware and ending up with the application, which is where we usually try to, search for the problem. Okay, so Log4Shell, for those who don't know, it's a very interesting thing because the code that was actually exploitable lived there since like version 1.1 or something, right? It was very old code. Also, that code was sort of exposing the URLs, the standard that was actually not used for like a decade, at least. I mean, if you're a Java developer, when was the last time you actually loaded configuration from a JNDI? I mean, if you know what JNDI is, that's another thing, but and in my experience, that well, never happened like for the last decade at least. But the code was there and actually was exploitable, right? So, and I'm pretty sure like 99% of applications actually didn't use that feature at all. So basically, that raises you know an interesting question. Anything that is not used actually should not be there, right? And especially you know something that GMDI LDAP protocol to retrieve you know configuration settings for your logging framework. What the fuck? Yeah, that's what probably a good question for developers as well. How much of the code that you have in your code base is actually used? Do you know that? Probably not.
How to find out it?
Well, there are many ways. Of course, the first one would be to see what kind of features are being used in the application and remove anything that is not used, which could be quite often extracted from the metrics of the usage of the application. You can also use code coverage tools to do the analysis. Maybe, let's say you have a functional test. You enable the code coverage. You run the functional test, whatever it is, like it's a Selenium test or some unit test suite, and then you analyze which part of the code actually were not invoked. And if it's not invoked, there's a high probability that this code actually is not used at all. Yeah. Also, if we're talking about not our code, but like code, the dependencies of our code, then of course we should use like vulnerability scanners, and also we can use, in general, like path scanners of the code to understand which part actually being invoked. The same code coverage can actually help as well here. But yeah, it's something that you as a developer probably should do from time to time, because it's a potential security problem, but also it's a potential maintainability problem. So the more code you introduce, the more code you have to maintain. And that's eventually will become a challenge. Actually, I've seen, I was on a project, it was like, the project was like 1 million lines of code, which evolved like within like 15 years of time. And people there were actually afraid to delete code because they thought it actually was used by someone. We actually analyzed and realized like 30% of the code base was never invoked in production, and we removed that. It increased decreased the build time, right? We started building faster. The unit test started to run faster as well, yeah, we just probably removed some security breaches as well with that thing. So yeah, that's observation that it's more thing that you probably have to think a bit about. Yes, returning to the log4shell. I mean, it was so big that in Docker Hub for some time, every image that didn't have log4shell vulnerability has had this badge. The problem is, this is a Python image. Python image cannot have log4shell because it's a Java library. But still, just for those who were scared, that's there. Actually, it reminds me once I saw a salt package in the shop, which was saying like GMO free. If you know what salt is made of, you probably know that GMO is not part of that in any case. The same is here, GMO free. Right. Yeah, I will skip SolarWinds. I will leave it for Ilya. And have you ever heard about this library? browseraluod. It's actually a very useful library for disabled people, for people with problems with hearing. It can read the contents of the site. So actually it was used by many government sites to help disabled people to actually understand what's on the site. Very useful. The problem is that it's a third-party library that was supported by the third company. And what happened is that somehow the provider of the library was hacked. And the browseraluod.js was actually published on S3 bucket, which for some reason had the permissions to write to that. The hackers managed to introduce malicious code into that, right? Of course, Bando didn't notice that. They just keep publishing the code, and it was always the latest version that was under this URL. And hackers were continuously, refreshing the hacked version. Then, of course, the clients of the library, the government end users and companies who were using the library, they were just inserting the link to the vendor inside the HTML, right? And of course, the HTML was always late, the JS library was always latest, and they didn't notice that because they relied on the fact that browseraluod will actually do the right thing with security. And of course, the poor users were loading the government website. Of course, the library was loaded right away, and starting mining of cryptography on your device, whether it's a laptop or it's a mobile phone. It is actually possible to do a crypto mining in JavaScript in the browser. And they did that. They did that, and they didn't notice, right? So you can actually imagine, how big this attack was, right? So the only thing that hackers did, they hacked one vendor, and it affected many clients and many users in the end, like millions of users. And how was it detected? Actually, the good thing that some companies run security software that scan the pages that you load into your devices. And it actually, the security software actually noticed that there's something fishy going on here. The investigation actually started. But yeah.
But does it know how they get to this bucket?
No, actually the vendor didn't discover that.
Okay, maybe just a lost password or something.
Maybe somebody somewhere left, the keys, and somehow vendor was
some
hacked.
Wi-Fi connection maybe.
Maybe.
Most of it.
Yeah, but it was a public JavaScript library that was trusted by many clients, and users by proxy were also trusting the clients. And yeah, eventually the radius of the attack.
Some client want to get free all, yeah. Unhack it.
The thing is that it actually was found out like within a few hours. So some security officers and some government just knew about that within a few hours. But it actually took forever to fix. Because first of all, vendor didn't want to accept that it's their problem. Also, the sites that were using the library also didn't want to accept that they need to fix something because they thought, okay, it's a library. How harmful should it be? And actually, many people were not, like the client projects were delivering websites to the final users. They were not educated enough to accept the fact that JavaScript library can actually be harmful and can actually do some bad stuff. And of course, I mean, at the time, I think it was 2018 or something, cryptocurrency was on the rise, right? So of course, the cheapest and the fastest way to get money was obviously doing some crypto mining.
But then, the blockchain integration that you need with MetaMask, we can build up the money.
Yeah, but that was they did that. But the thing with blockchain is that it's anonymous, right? It was a hard-coded blockchain address that was giving money into that blockchain address. You cannot know who was that. You can only see how much money has been generated with this using the user device. So actually, for users, it was not that harmful. The hackers were using their compute capacity. That's it. But imagine if hackers were actually a bit smarter or a bit more hackish. They would actually keep the code as silent as possible and would try to steal some secrets like credit card numbers, personal data, because basically the JavaScript was loaded into the browser and was running there unnoticed, right? And you can load any code. Any code that will read the cookie, send it to the address, and of course there are mitigation strategies that can help you avoid that. Of course, forced headers, you have to introduce that without question. Also, there are several elements in the HTML that now allow you to kind of verify that the checksum of this JavaScript file actually matches the file itself, and it's actually there for like a decade. But many developers prefer to use the latest version. And that's what it will get to, right?
But does this library was not updated from the developer side?
Eventually, but it took.
If it was updated, you must see some.
It took weeks.
They used only the same. That's the problem. And most of it, we wrote in the Web3 version. They used JavaScript. Yeah. They always take, we take this code, and they always take up with that code, and then don't see all what you write down there. Yeah. Now always to take a package, and that's a problem.
Yeah,
most of it, whether you do take up yourself, not better they take some new product that you don't see.
I'm just talking because of differences. If you're doing some updates, you see it's not mine code, some differences in GitLab and so on.
This is if you have the build pipeline. This is like this was typically you just have this in the page header with like just load it.
No. If the developer updating cloud library, he must to see some differences between his last commit and new one.
But it's not about the commits. It's about the final
Publishing
on the S3 bucket. So it's a final delivery. So basically, it's in them probably with their pipeline. They created the library, and minified version is published on S3 bucket.
Yes.
And then that's it. They don't know what's happening after that because.
And every time they updated library, someone was injecting this code again.
Yeah.
Okay.
The fresh new one. They want to choose that.
Yeah. But my main point here is that just imagine how big the radius of the attack could be, because especially if you didn't inject that in a very popular library, then you can affect lots of devices on the planet and steal lots of data, and that's dangerous. If you want to know more, there's actually a video of that browseraluod attack. A few more details in there, so yeah, feel free to do that. I'll share the slides after that as well. Do you know this guy? Yeah, basically, it's also hackable, right? And this is from 2018. Somebody has injected a malicious code, actually stealing credit card information, and it managed to deploy that to it was downloaded 2 million times, 2 million times a week.
Yeah, put 1 cent inside, and then you see how much you can do. There is always free to code. They collect, they choose that, and they'll put something new.
So what happened on the NPM level? Have you heard of this guy?
Yep.
Yeah.
LeftPad. I mean, actually, it was not an attack. It was more like, an act of disobedience, or like a person was really angry. Because the lawyers requested NPM to remove one of his packages. And because he was angry with that, he actually removed all of his packages. So, including this one. And it appeared like millions of other packages and sites and everything was dependent on that, which broke the build for like at least half a day, maybe a day, for the whole plant. So as you can imagine, packages can be quite dangerous. There's more on the story there, and maybe you've seen this package in NPM. It's actually a real package. It's there.
Yes.
This
is not solved. This is still a problem in front of you.
Yeah, and then you can see how many times it's been downloaded, right? Actually, is odd is just calculating if the number is odd or not. There's also is-even package, which does the opposite, but actually is calling the is-odd package, or the other way around. Very useful. Actually, I think it was created as a joke, but the amount of downloads that happens weekly still is crazy. Yeah. Also, have you seen this package? It's just minus or hyphen. Actually, if you run npm -i minus, maybe making a typo, you will actually download the package. So you see, it's quite easy to get some code into developers' laptop. So I mean, of course, if you make this mistake and you download the package, it's not really dangerous because the package is just downloaded. It's not runnable, right? You don't activate that. But potentially, if some other script, some more sophisticated attack will play out, and we'll assume that you have the hyphen package, and it will eventually invoke it. Then actually, there's a package called -i. Basically, every npm parameter, there's a package for that. I don't know who did that, why they did that, what's the purpose, but if you look at the number of downloads, it's just crazy. Of course, what can we do? Don't use stupid libraries. Or don't use the libraries that use stupid libraries. Don't use the libraries that use libraries. Use stupid libraries. But you get the point, right?
How to define which libraries are stupid?
This is but
Don't talk about collaboration.
This is not solved.
Tomorrow it will be more.
yeah, most likely, most likely. Of course, we need to understand where our dependencies are without the question. And one way to kind of mitigate the problems with leftPad, when somebody removes the package, you can actually have a library cache in your own organization as a mitigation option. And another option that you have to enable, of course, is you have to analyze what you use and what these things actually are known for, the bad things that they're known for. Without analysis, it's important. It's not happening. Have you heard about ASBOM?
Yes.
And Ilya will talk more about that. Software bill of materials, which actually is quite an old standard. I mean, it's like more than a decade at least. But with latest things that happen in the security world, this is becoming more and more important because we basically software bill of materials allows us to collect information not only about our applications but also about any other infrastructure or software component, and keep it up in one place so we can understand what's dangerous, what's not. Because obviously we have lots of components to worry about. That's the tool I use. That's also from of us. And that I use it like for application analysis and aggregate then vulnerabilities for the apps and dependencies that we have in the company. It's actually quite simple, but also quite powerful. Also relatively old. It's more than like 10 years old. The other way, of course, static analysis tools. I guess at least developers know that. You know, SonarQube and different other vulnerabilities, not vulnerabilities, kind of like code scanners. Some of them actually are mostly focused on design problems or formatting problems, stuff like that. But also many of them also have some security built in. And of course, it should be part of the pipeline, no doubt. One problem with static analysis tools and also with dynamic analysis tools that one of them is ZAP, is that actually quite many false positives. So I mean, it doesn't mean that static analysis, dynamic analysis is bad. It's just that you have to be prepared. There will be a lot of false positives and sometimes false negatives. Also, the other problem I see with static analysis is that risk assessment is actually quite often out of context. So you get a generic statement that this library is vulnerable, or this piece of code seems to be not using the right way of defining random numbers. And then it seems like it's important and you want to fix that, but when you look at the context of where the application actually is deployed, you realize that actually the code is not invoked anywhere, or this code actually is test code, or this code is actually protected by some other measures. So static analysis also, unfortunately, they are quite often out of the context. They don't put the details about where we deploy the app into the context. Also, actually, it's also quite difficult. I mean, how many times have you configured, for example, SonarQube? Anyone? Have you fixed all the errors?
No.
Not always.
And actually to make use of SonarQube or any other static analysis tool, you have to spend time on finding out which issues actually are important. And quite often, I mean, I've seen it many times. Like a new developer comes into the project and he sees like and says you don't have SonarQube, let's enable it. And then you have like 10,000 warnings. Now let's fix them. No, we have no time. And then you live with 10,000 warnings, and then for a long time, nobody fixes them. Everybody ignores the SonarQube. So of course, in order to make value out of any static analysis tools, you have to invest into understanding which rules we're enabling, why we're enabling them, do we provide extra context, and without that, it's actually quite useless. And also, of course, well, nothing guarantees that code is secure, especially the static analysis. Right, so that's the other thing that is extremely important. And I mean, when we talk about applications, quite often we omit that, right? We don't talk about that, especially like from developer perspective. We don't care. Do you know what is CM? Yeah, some people know. It's Security Information Event Management, or something like that. So basically, that's collection of the events happening in the security context of application infrastructure, your cloud providers, whatever, your SaaS solutions. So basically, the different types of audit logs, different types of audit events that are coming up from different components. And what I find is that when we talk about, let's say, some APIs, let's say a backend API, front end with nice GUI, something like that, we talk about maybe API security, but we don't talk about collecting of the security information, right? So quite often applications do not produce the audit events. Of course, if we talk about, let's say, something like Microsoft 365, or we talk about, I don't know, Google Workspace, they do have audit logs, and you can collect them and analyze them. But what about your applications? What about the applications that you create? Those folks also should produce some security information that you have to collect. I mean, it's extremely useful when the breach happens, because, well, it may happen, may not happen, but if it happens, you would really appreciate the fact that you have the data. At least the logs, but maybe also think about, you know, different audit events. For example, if you're working with things like LeftPad, you probably want to log information about system access in some way. So you want to understand when different citizens are accessing different types of functionality. You want to have the audit log for that so you can analyze that. Because if attack happens, you want to understand from where it comes, who is responsible, which potential credentials of which citizens have been stolen, and stuff like that. You want to know that. If you don't collect that, obviously that's a bad thing. So CM is important. So event collection should be, if you're talking about, you know, development part, it should be part of the app, for sure. The other thing that is extremely important of any security team, actually, I think this is the sole responsibility of security team to do that, is to detect anomalies. Because quite often, you will collect lots of data, you'll do lots of analysis and stuff like that, but the breach happens. When the breach happens, usually it's not normal, right? You see some spikes, you see some unusual behavior, and you have to work on your anomaly detection mechanism. Of course, there are many commercial tools that can help you with that. If you use like Elasticsearch, for example, has a package to do anomaly detection. You know, there's lots of things, but you have to think about that. It's an important thing. And of course, nowadays, with different AI tools and machine learning tools, that's probably one of the use cases where it will be super useful, and I think will be more products will appear in the security domain, which will actually do analysis of security events with the help of Gen AI. The other thing that I find extremely important is actually education, right? And threats and risks is something that quite often is not fully understood by the team. So if you gather, like you say, let's say developers, QA people, DevOps people, security guys, all the actors will have a completely different understanding of what is the risk. Of course, security people will be, you know, more aware of the risks, but usually the other parts of the development process, of the delivery, will not be as educated or not as aware or caring about some of the risk of threats. What I find is helping, and I did that in several teams, you do Agile, right?
Our own one.
Oh, anyway, if you do in some sort of Agile, your own one or not your own one, then you probably do retrospectives, right? And usually retrospective is about what gone wrong, what gone well, and what if you, in your next retrospective, you include a security concept, security topic, and just discuss the security, right? Do security retrospective on your app, make like, you know, high-level design of your system, and try to, on that diagram, I don't know, you use Miro or Mural or something like that, and try to put the risks and threats for your application. Invite security guys, invite developers, invite DevOps people. You would be surprised how much actually is not known by the public in your organization. So security, like quality, right, like testing, like any other aspect, like automation. If you don't talk about that, it doesn't develop. If you don't talk about security in your team, if you delegate that only to the security team or security department, whatever, then it will not happen. In order for that to happen, you have to talk about that. Just as simple as that. And retrospectives could be a good way to do that. Yeah, security retrospective, and well, actually, security guys probably know that there are many different models out there that allow you to create threat analysis or risk analysis. You just Google that as threat modeling, you'll find like 7 different models. One example could be Stride. So you analyze your architecture or your application infrastructure based on this like 6 elements, like identity theft, is it possible or not? Is it possible to sabotage, like do DDoS attack or something like that, or do some malicious data insertion or something like that? Is it possible to kind of do some impersonation or something like that? Is it possible to get data from your customers through logs or through metrics or through some other emails maybe, or like some malicious emails, stuff like that? Because, of course, if we talk about just the application code, then quite often the answer will be no. But if we talk about the whole infrastructure, including all the services that our application consumes, then actually the answer could be maybe. And then you actually discuss that and then open that. Denial of service, elevation of privilege, yeah, this is right. The other one, it's called DRAD, it's a bit different focus, different perspective. Basically, you can actually take the vulnerabilities, for example, that you already discovered in your scanning or something like that, and then you can try to analyze how much damage actually this exploiting that vulnerability will bring. Is it huge damage, not huge damage? How easy it is to reproduce, how easy it is to exploit, how much it will affect the users, how many users will be affected. Like if it's one user in the finance department, whatever. But if it's like millions of users, then of course you probably should take a look at that. Discoverability, is it easy to discover that? Yeah, if it's easy, then it's probably the first thing you have to attack. I mean, when you start tools like SonarQube or different vulnerability scans, you'll have lots of different things that you see. And maybe this model can help you out to figure out which are the priorities, right? And then act on that. Because basically, what you do, well, especially developers or testers, what you do with bugs, quite often you assess what is the potential effect of that bug on the users, and based on that you do some triaging, right? You select which bugs have to be solved first. Actually, the same thing, the same mechanism is happening in hospitals. Have you ever been to hospital?
No, not too much.
Yeah, but basically when a patient is incoming, right? They will they will categorize them like depending on the hospital in 5 or 6 groups. If you are in the red group, you'll be taken care of like immediately. If you are in the blue group, which is the last one, you can wait there like for days, and nobody will take care of you. So the same thing is about about any information that you get, like about bugs, about vulnerabilities. You can basically triage that based on the potential risk and the likelihood and impact, right? So that's the thing that you should do with vulnerabilities as well. Yeah, there are more stuff. So my ideal state of a team, of an organization that does security right, is that security is everyone's responsibility. We do static and dynamic testing, but we don't, focus too much on that. We do data collection like CM events. We do anomaly detection. We do threat modeling, and we do retrospectives. That's my ideal state. Thank you very much.
Question.
Sure.
Can we return to the previous slide, the ideal state?
Yeah.
So this is all about detection.
Yeah.
And now we detect it. And we know that there are vulnerabilities. And we need to patch them.
Yeah.
And we have containers. And we have base images for containers. And there are a lot of dependencies was mentioned in the very beginning. And we have a lot of dependencies. And now I ask, please patch them. We cannot patch them because there are a lot of dependencies. Okay, how to approach this? We probably need 2 more people to deal with that.
Mm-hmm.
Maybe we can automate. We are not the only company with this problem. We believe that there is no tool to automate all these dependencies and patching process, because this is kind of quite difficult task. And then the question, is there something to help with this process to automate patching of containers, some extent maybe.
Industry.
Well, I mean, if you're using something like OpenShift, they actually have a tool that can patch the base image without changing the application. So they have layers. Also, if you're using Lambda functions, they also have layers. You can also patch the layer, the higher layer instead of patching the application layer. That's a possibility there. But in general, of course, this ideal state also assumes that you have well-defined and well-working continuous delivery process. So you can actually release quite fast. If you can release quite fast and you can release every application in your organization, then you're already good to go. That's already security protection sort of. If you don't have that, if you have some legacy deployment procedures or legacy patching procedures for your servers and stuff like that, then you probably have to address that first. Because my assumption that we actually do continuous delivery here. So continuous delivery is, there's another thing that is important, which I didn't mention. But if you're talking about what to do if you don't have that, if you don't have pipelines or scripts for deploying some applications, I mean, you have to triage that. You have to understand which ones are more important and fix them first.
We have, but they use some kind of hard-coded versions and kind of refusing to update.
Then it's not a security problem.
You can learn something new.
You can talk them and
But I mean that asking for just updating this is most probably will break some functionality somewhere.
The question is about the test coverage. So then how big is that? I mean, it's continuous, but basically the answer is continuous delivery. Because if you actually do continuous delivery, not just the pipeline, but actual continuous delivery, then your test coverage will be quite high. I mean, we just returning back to the basics.
How close this is to NIST framework?
NIST, JavaScript.
NIST.
JavaScript framework.
No, it's not next.
NIST?
No, NIST.
NIST framework is a framework for security posture and standards.
Okay, I didn't know that. Maybe you can show me that later.
Okay, and one more. It said the threat modeling is included. What about attack modeling?
Actually, yeah, it's in there. It's in there. Maybe I was not precise in wording, but it should be there.
But well, you should dread and strategies more.
Yeah, actually, the right element should be like threat and mitigation modeling. So we also have to plan the response. That's another thing. Yeah.
How would you, I don't know, put in categories? Because everyone's always talking about third-party libraries, and you're presenting it. So everyone knows we have to scan them. We can deliver also some garbage library and so on. But actually, how important is to scan, for example, CI platform? Because I have read now lately, for example, in US latest USA cybersecurity and infrastructure recommendations, they even go as far that they are saying everything that touches your code should be scanned. They should go, and they even go on the borderline, basically saying that you have to also, I don't know, transport lie detector on your employees, close to that basically. So. How would you categorize it? Because, for example, I'm a security manager. I understand that there should be some boundaries.
Mm-hmm.
How do we split this?
I mean, if we're talking about the modern CI pipelines, most of them are Docker-based. They're based on Docker images, and of course, you have to scan those Docker images so they don't have any problems with security. But also, of course, scanning the pipelines, yes, it depends on the complexity of the pipeline. Because my your usual goal is to define the pipeline as simple as possible. So they just invoke a couple of tools and that's it. And then the rest maybe is done somewhere else. But if your pipeline is very complex, and obviously scanning that, well, I don't think there's actually a tool that can scan a complex pipeline. But if you, let's say, package your pipeline into scripts and scripts with the Docker images, then you can actually apply scanning to that. Because, for example, you can use shell check to scan the shell scripts, bash shell scripts, and get some vulnerabilities back. You can scan, using Docker Scout, you can scan Docker images and get some vulnerabilities back. So I think it's about packaging. If you package your pipeline, not in a like clumsy YAML / bash kind of code, but you actually package that into reusable blocks with scripts and images, then it's becoming easier to scan.
I was more thinking about tools themselves. For example, Jenkins, or we are using Ansible, or even the IDEs the developers are using. Should we really, because there are instances where I know that that company is really focusing on those third-party, like scanning everything each day. But for example, they are using Jenkins version that is maybe 3 years old.
Okay.
I think
that's a problem.
But should you focus on that? Is it really that important? Or even scan, or even control IDEs, versions of IDEs the developers are using?
I would say version of IDE, maybe not. But version of Jenkins that is like 3 years old, definitely.
But Jenkins itself, it is not directly involved in packaging. For example, Java or like Maven, okay, problem with the Jenkins.
Yeah, but potentially, if Jenkins is vulnerable,
yeah.
The bad actor can get into your pipeline and do some install some extra plugin that will do some injection of the code, and you will not even notice that. Yeah. So of course you have to scan Jenkins because it's a critical component of your software delivery.
So we should treat it basically as the same as some third party.
Yeah. Especially Jenkins. I mean, Jenkins is well known for having lots of security vulnerabilities in the past. They fix them quite fast, but still, it's a quite a dangerous tool.
I wanted just to elaborate on this. Like the question is kind of open-ended, and it really depends. It depends which area you're operating. Is it the military? Is it medical? Is it just generating the kitty images, right? So, do you have like a separate security guide? Do you have a certification? It all like typically on a startup you start with nothing, and then you just like build it up. You try to strive for the best.
Yeah.
You never reach this like ultimate like we're secure. Like the only like you typically you are limited by the budget.
And you have to triage things.
Yes, exactly. This is like actually made a picture of this. Is like this is simple and genius. It's like you every day you literally decide like, is this risky or we can live with this?
No, that's exactly what my point is that especially in companies where we have internal tools which are not exposed to those. Basically, sometimes the thinking is like if it's internal, we don't even need a login. We can just use 10-year-old version and nothing will happen.
If it's airtight, I would say, like if you can make if you can make it airtight, it lowers the risk. But it's still risky. Human factor, like just spoofing, like human factor is always the case there. It's like the more you know, the worse the sleep is typically for the security.
I mean, and the goal for security people is not to reduce risk to zero, but actually to reduce risk to minimal possible value that is also financially viable.
Minimize the surface.
Yeah,
it's all about minimizing the attack surface.
I just wish to say that this may be not always the easiest way. So how you calculate this likelihood and impact, how you calculate this impact for the organization.
Subjective, I mean.
It's always subjective. We will spend hours on discussing how big is an impact. It's more often easier to update and forget.
Well, sometimes, yeah, sure. I mean, It doesn't mean you have to calculate it, it's just...
It gives you the answer to update now, or we can live with it. Like, that's in the context.
But with update you can get new vulnerabilities.
That can happen too.
Unknown yet.
Yeah, there are moments where there's nothing to update. It's like there's a CV open, and it's like, you wait.
Let's continue this discussion and break.